Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will review what was covered in week 15. So week 15 was all about improper fractions and mixed numbers. Now previously we'd only looked at fractions like these, where the numerator, top number, was less than the denominator, which is the number on the bottom. So numbers like 1/5, 2/5, 3/5, 4/5, they are all proper fractions. Now they're all less than 1. Remember, 1 would be 5/5 if we divide the number line into fifths. And of course 4/5 is less than that, so too 1/5 is less than a whole. So this is what we're used to dealing with, but this week we looked at a different type of fraction called improper fractions. So remember I said 5/5 is equal to 1 whole, so 6/5 or 7/5, these numbers are more than 1 whole. Improper fractions, which are more than 1 whole, they occur when the numerator, the top number, is bigger than the denominator. Top number bigger than bottom number. So because each of these are more than 1 whole, we can write it as a whole plus a little bit more. Each of these can be written with a whole number plus a proper fraction. When we write it in this way, the way I've done in black, we call these mixed numbers. Mixed because they include a whole number part and a fractional part. So the reason that, for example, these two occupy the same position on the number line, they are equal. 1 1/5 and 6/5, they're both equal to 1.2. If you got 6/5 of a pizza, you'd get exactly the same amount as if you got 1 1/5 of a pizza. So you're probably asking yourself, well, why would I write the same number in two different ways? Why do we need both of these? Well, mixed numbers are easier to deal with, so we really want to know about those. But when we want to perform operations with mixed numbers, it's so much easier to use improper fractions. That's why we need both. Now, any mixed number can be written as an improper fraction. Any improper fraction can be written as a mixed number. So let's look at how we convert between the two. So let's look at this number here. So this is clearly a mixed number. It has a whole number part plus a fraction part. So it's 6 5/7. So this number is more than 6, but less than 7. So how do we convert to an improper fraction? Well, what you do is you times the integer, the whole number part, by the denominator, and then you add the numerator. So 6 times 7 is 42, plus 5 is 47. So that becomes our new numerator. 47 goes on top, 6 times 7 plus 5. Now we always keep the same denominator when we're converting between mixed numbers and improper fractions. So 6 5/7 is equal to 47/7. So what about this? Well, this is clearly an improper fraction because numerator is bigger than denominator. How do I convert this to an improper fraction? Well, remember this line here actually means divide. So we're really saying 32 divided by 5. So how many times does 5 go into 32? Well, it goes 6 times, remainder 2. Once again, I said when we're converting between mixed numbers and improper fractions, the denominator always stays the same. So how do we get this? So you do this number divided by this number. The whole number part becomes the integer over here. The remainder goes on top, and the denominator stays the same. All right, let's look at some operations with mixed numbers. So as I said, mixed numbers are easier to understand, but when you're performing operations with them, we want to use improper fractions. Then we can just add, subtract, multiply, and divide the way we've done in previous lessons. So let's look at this question here where we have a mixed number divided by another mixed number. Let's convert both of them to improper fractions. So 1 times 5 plus 3 is 8, so 8/5. 1 and 1/15 becomes 16/15. So the way I divide fractions, you already know this. I keep the first fraction the same, flip the second fraction, and make it a times. So when you have big numbers to multiply, like 15 and 16, you might want to look to cancel. You can cancel anything on the top with anything on the bottom. So 8 goes into itself once and goes into 16 twice. 5 goes into itself once and 15 3 times. So I'm left with 1 times 3 over 1 times 2. So I get 3/2 or 1 1/2. and then I'm done. All right, let's look at this one. So again, I'm going to convert each mixed number to an improper fraction. So 4 times 12 plus 7 is 55. So 55 over 12. Next one, 2 times 11 plus 2 is 24, and I keep the same denominator. So again, it would take me a while to do 55 times 24 without my calculator, so I'm going to look to cancel. 12 goes into itself once, goes into 24 twice. 11 goes into itself once, and 55 5 times. So now I just need to do 5 times 2, which is so much simpler than 55 times 24. The answer I get is just 10. Sometimes when you're operating with mixed numbers, you can get a whole number answer. All right, let's do this one here. So 3 and 1, 8. 3 times 8 plus 1 is 25. So I get the first fraction turns into 25 over 8. 2 times 6 is 12, plus 5 is 17. So I get 17 over 6. All right, remember, when you're adding or subtracting two fractions, you must first make them have the same denominator. It doesn't matter if the denominators are different when I'm dividing or when I'm multiplying, but when you're adding or subtracting, the denominators must be the same. So the lowest common multiple of 8 and 6 is 24. So I'm going to make each of these denominators 24. So if I times top and bottom by 3 here, times top and bottom by 4, I will make the denominators equal to 24. So 25 times 3 is 75, 8 times 3 is 24, 17 times 4 is 68. Remember to times by 4, you double it, then double it again, and 6 times 4 is 24. So now I only subtract the numerators, so 75 minus 68 is 7, and I keep the same denominator, 7 over 24. So sometimes when you perform operations with mixed numbers, you get a proper fraction as the answer. All right, let's just do one worded problem now. So Lachlan runs this far every Tuesday, this far every Wednesday. We're going to calculate how far he runs every 3 weeks. So first, let's calculate how far he would run each week. Well, all we have to do is add together the distances. This is how far he goes on Tuesday. This is how far he goes on Wednesday. So to add these two mixed numbers, we're going to convert to improper fractions. So 2 and 1/5 is 11 over 5. 3 1/2 is 7 over 2. So to add together two fractions, they need to have the same denominator. So lowest common multiple of 5 and 2 is 10. So if I times top and bottom by 2, top and bottom by 5, both of these fractions will now have denominator 10. I get 22 over 10 plus 35 over 10. So now we just add together the two numerators. I get 57 over 10. That's how far he goes each week. So in 3 weeks, he would go 57 over 10 times 3. So remember, when you're timesing by a whole number, you write the whole number over 1. So I know it's not easy to do, but 57 times 3, just go 50 times 3 is 150, 7 times 3 is 21, it's 171 over 10. Now, making this a mixed number, how many times does 10 go into 171? Well, that's obviously 17, remainder 1. So he goes 17 and 1/10 of a kilometre every 3 weeks, and then we're done. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Keep up the good work. Have a great day.